At the orthocenter of a triangle. The orthocenter is actually where three altitudes of a triangle. An altitude of a triangle is essentially the height of a triangle, and you can measure it from three different sides here. Here's one, I'm kind of running out, and the other one may be there. And it's where they would all meet, would be the orthocenter, okay? So it's usually considered the height of a triangle. I've quickly plotted our points over here. We have 2, 8, 0, 0, and 5, negative 4. Again, the purple lines, they're just there kind of show the triangle. I've extended them mainly because if you notice, to be perpendicular to this point here will actually be outside of the triangle to find the height of that side of the triangle. This one would be in here, and this one might also be outside. So I extended two of the sides dotted meaning it's outside of the actual triangle, just so you can see that idea. So we're going to play with these values here. The first thing we need to do is figure out perpendicular sides to these triangles. So we're going to have to find the slopes. So let's get our pen out ready here. We're going to find our slopes. So when we find the slope, we'll start with AB. Okay, and to find slopes, slopes usually denoted as M. We're going to take our y1, subtract our y2, so that's going to be negative 4 minus 8 divided by 5, subtract 2. That'll give us negative 12 over 3, which is the value of negative 4. Now, we need it to be perpendicular to that. So negative 4 as a fraction is negative 4 over 1. And we need something that is perpendicular to that. So it's a negative reciprocal. So it's going to be a positive value, and it's going to be 1 over 4. So what that means now is our line of our altitude is going to be written as y equals 1 over 4x plus b. We just don't know what the b is. We do know, though, a y and an x value. And if we go take a look, our y and our x value, we did line AB, which is 2854. So 2854, the height of that is going to be 0, 0. So we're looking for the side opposite of it. So we're always going to use the side that we didn't use for slope. So in this case, that would be our C value. So that's what we're going to plug in for our y and our x here. So x ends up being really easy. We have 0 is equal to 1 over 4 because our C coordinate was 0, 0 plus b, which means our b value is 0. So the equation of our first altitude is y is equal to 1 over 4x. So let's go ahead and plug that in. Y equals 1 over 4x. And there we go. This line is now crossing through the opposite vertex, and it is perpendicular to this side of the triangle here. It doesn't quite cross at the midpoint, it's just figuring out the height. So if you really want to know the height of this side of the triangle, you could take these two coordinates, and you'd have to find this coordinate by finding the intersection, and you could find the distance. But we want the orthocenter. So this, where they're intersecting each other, isn't as important to us. Let's play with another side here. Another side we're going to work with, let's work with BC. Okay, so same idea, we need to find the slope again. So our M for BC is going to be, we'll take negative 4, subtract 0, not equal to. Oh, that's funny. That decided to undo that part. Here we go. Sorry. Negative 4, subtract 0, there we go. And 5 subtract 0, which is going to give us negative 4 over 5. We need something to be perpendicular to that to find the slope of our altitude. So perpendicular to this will be positive 5 over 4. So we know that our altitude for our second line is going to be y is equal to 5 over 4x plus b. To figure out what b is, we need to get an xy value. And since we used BC, the xy value we're going to use is 2 and 8. And we're going to plug in 8 for y and 2 for x. So when we do that, we'll get 8 is equal to 5 over 4 times 2. And it's technically 2 over 1 plus b. So when we multiply, we'll get 8 is equal to 10 over 4 plus b. We bring 10 over 4 over. It becomes 8. And I'm going to turn this into an actual fraction, and we need it to be a denominator 4. So I'm going to multiply both the top and the bottom of this by 4. I think we changed the line sizes. Yeah, we did. Okay, which means this is going to be 32 over 4. And this will become, subtract 10 over 4 is equal to our b value. I made have shrunk down one. No, that's the right one. Okay. And that's going to give us 22 over 4 is equal to our b value. So our other altitude is y is equal to, the slope was 5 over 4 4x, and plus 22 over 4, which I think is 5.5. But we're going to just write that equation in. So y equals, what was it again? 5 over 4x plus 22 over 4. And there you have it, and that's exactly what it is. The height of this triangle would be the distance between these 2 points, okay? And what we need to find out for the orthocenter, again, which is outside of it, I'll change it to red so you can see that the altitudes are all in red here. There we go. The orthocenter is where the two cross. Now, technically, all three will cross there. But because all three cross at the same spot, to make it easier or less amount of work for us, we only really have to solve for where two cross. This is the value where they cross. We're going to prove that on our other side. So now that we have our two equations, which are written right here, we'll do this part in green. What we're going to do is we're going to set them equal to each other. So we have this is equal to this. So it's the idea of we're going to take this value and we're going to plug it in for the y over here. So we get 5 over 4x plus 22 over 4 is equal to 1 over 4x. Great. I'm going to move my x values to one side and my constants to the other, so we get 5 over 4x minus 1 over 4x is equal to, and this becomes negative 22 over 4 when it moves to the other side. When we subtract this comes to be just x, so it works out great. It's equal to negative 22 over 4. So, and that helps us find our x value, negative 22 over 4, can also be written as negative 5.5, which we can see over here, our x value being negative 5.5. And in order to find our y value, we're going to essentially just take this value and we're going to plug it into one of our original altitude equations. I'm going to choose this one up here because it's got no y-intercept to it, or the y-intercept is 0, so it'll be a little simpler. Y is equal to 1 over 4x, and we're going to plug in this value for the x, and then we're going to multiply. So we get y is equal to 1 over 4 times negative 22 over 4. Y will be equal to negative 22 over 16. And when we plug that into our calculator, negative 22 divides 16, we get negative 1.375. And negative 1.375 is exactly our value. So that is how you can find the orthocenter of a triangle.